Oh, I just got rid of all my old Christmas cards. Write this down. Here is a coordinate system. And we've got a rectangle that is at 0, 4. 1, 2, 3, 4. 0, 4. 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. 2, 6. 0, 4. 2, 6. 5, 3. 3, 4, 5. 1, 2, 3. And I suppose the other one is probably at 3, 1. 1, 2, 3, 1. So we have this rectangle. Isn't that a lovely rectangle? Number 1. And you are asked to find the area and the perimeter. And it seems to me we've already done this, so I'm not sure why it comes up as something new, but perimeter. I don't know what my thing is. I really should probably get rid of. Give me a second here to get rid of this. This thing seems to be messing me up. Maybe this is better. Alright, how am I going to find the area and the perimeter of it? The first thing you need to do is find the sides. And we talked about this for how do I find the lengths of the sides? Anytime you're given a grid, you know, you can't just count and go, oh, that looks like it's 3, or that looks like it's 5, or whatever it is, maybe it is, maybe it isn't. Anytime you're given a grid, you will always be able to use right triangles. So you want to draw, to find this side here, this is the hypotenuse of this right triangle right here. And you can figure out by counting the sides of that, which happens to be what? This is 2 units, I believe, and it is 2 units high. And the reason we're calling this working with radicals is because it's not going to work out evenly, so you're going to have to be able to deal with that. So using the Pythagorean theorem, a squared plus b squared, 2 squared plus 2 squared equals c squared. You get 4 plus 4 equals c squared. 8 equals c squared, and c then equals the square root of 8 is the square root of 8, right?
Yes.
No.
No.
It needs to be simplified. What is the square root of 8?
2 times 4.
Square root of 8 breaks down to the square root of 4 times the square root of 2, and the square root of 4 is 2. So this is 2 times the square root of 2. This is 2 times the square root of 2. Then, once we figure out the other side, this will be a piece of proverbial cake.
What does that mean?
Proverbial cake?
Yeah. Proverbial.
Well, a piece of cake is a cliche or whatever thing.
Well, I know that, but what does proverbial mean?
It means it's said in a proverb.
You say it all the time, and I never know what you're talking about. That could be our favorite word.
What's our triangle there? This triangle is 3 high by 3 wide. I don't know if I like this color green. Let's try a nice shading. So the Pythagorean theorem for this is a squared plus b squared equals c squared. 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. C equals the square root of 18. Is that simplified?
No.
Square root of 18 is
2.
breaks down to the square root of 9 times the square root of 2, which is 3 times the square root of 2. Now the next part, children, is the part that you really need to know, because today's quiz has both of these on them. And we still struggle with it, and I'm not exactly sure why. First of all, the area of this is length times width. So the area is 2 times the square root of 2 times 3 times the square root of 2. Now, can I multiply radicals together?
No.
Yes, you can. Okay. You can always multiply. You can't always add. If they're unlike, you can't add them together, but you can always multiply them. All right? And when you do this, you then do 2 times, multiply the normal numbers together to give you a normal 6. The square root of 2 times the square root of 2 is really the square root of 4, but the square root of 4 is 2, so yes, it ends up just being itself underneath there. 6 times 2 then is 12 for the area of this. If I were to cut this into nice little squares, Andrew, I would get 12 of them. Well, you can't though. I mean, you probably could cut them into squares, but you're going to get a lot of triangles that you're going to have to try to piece together, and I don't know if they probably wouldn't go together. Huh? Well, you could, but you don't know. I mean, this is 2 times the square root of 2 wide. It's not actually 3 wide. It's not exactly, it'd be pretty hard to divide it into 3 equal pieces. Okay. Now the Kendall.
I'm just wondering, why didn't we just count the units on each side?
How are you counting them?
Like the right.
I tell you what, Kendall, you get me a piece of real graph paper, you draw this exactly out and come show me how you break that into complete
No, I was
squares.
wondering if like you could just like count the units in between the 2 things.
But there's no lines, there's no units here. How do you know the distance from here to here? Well, we know the distance, it's 2 times the square root of 2, it's not an exact number of anything. Kendall, that would work if your thing lined up on all of the X and Y lines, but it doesn't. It's on an angle. Secondly, perimeter then equals area of all the, or the length of all the sides put together. So you have 3 times the square root of 2 plus another 3 times the square root of 2 plus a 2 times the square root of 2 and another 2 times the square root of 2. Now, when I put all those square roots together, are they going to go away? No, they do not. Not when you add them together. If you have 3 square roots of 2 and add another 3 square roots of 2, now you have 6 square roots of 2. And then another 2 onto that is 8 square roots of 2, and another 2 onto that is 10 square roots of 2. They don't go away when you add them together, like they did here when we multiply. And you have to get that in your mind there, and that's... Kendall, are you going to tell me how you get 10 times the square root of 2 units for its perimeter? Any idea? Could you count that and get a square root of 2? Negative. And look at that. Isn't that a nice piece of paper?
You should show that to the 7th graders.
This is what we are. Tell them what it is they're in store for. Wait, let me look and see what's on the quiz so I can give you one more hint.
They haven't even known about
Yeah, that's where it's
All right then.